HW5. So, assignment number 5. You were given an array of coin diameters in millimeters. In this array called coin diameters, it's a list. Don't know how long, but there's some floating point values in here with diameters in millimeters of the coins. And you're given in the assignment, I just assigned these variables. So quart D is quarter D because I was too lazy to add an ER on the end. Is 24.26 millimeters. A dime is that. Nickel and penny. So I assigned these just to make it easier so I don't, like if I didn't assign these and I compared them, like if I said if the coin diameter is 24.26, it would still work, but it would be confusing to someone reading it that doesn't know what that's supposed to represent. So I say it up here. So it's like, oh, okay. The 24.26 is diameter of the quarter. That's why. So the balance that the customer has to pay off is 1,000 pennies because they have to pay $10 for that's $10 is the total of their groceries. So they have to pay 1,000 pennies. And also part of the requirements for the assignment is counting the number of each type of coin. So I just said quart count, dime count, nickel count, penny count, and foreign count, which is foreign coins that can't be used. So I'm also counting those because another requirement is that you have to count up how many foreign coins there are. Now the part that you need to learn is for loops. So for loop iterates or traverses an array, iterates over the array or traverses it. It's useful to know those two words because that's what they call it in programming. They call it traversing an array, traversing a matrix, traversing an object or a map, or any kind of data structure. It could even be like a tree or a graph. It could be anything. So for loops are just useful for looking through all of the elements in an array. We want to look through all of the elements in this to compare them and see the first one. Well, we can already tell it's a quarter because these are the same. It's the diameter of a quarter. So the way you create a for loop is you say for, and then you define your indexing variable. The indexing variable is just a number that you keep incrementing to keep track of where you're at. You can think of it like tallying. It's like making tally marks. So first I'm on number 1. I'm checking the first element, and then I'll add 1 to it. So I'll add 1 to I. Now I equals 2 to symbolize that I'm checking the second element. Then I keep adding 1. I go 3, 4, 5, 6, 7 through all of the elements. And eventually, let's say this array is 30 elements long. It's probably not. It's maybe more than that. But let's say it's 30 elements long. Eventually, I is going to equal 30 because I goes up to the length of coin diameters. Whatever that length is, I will stop at that value and the for loop will terminate. So it'll stop looping through and I will stop incrementing, and then it'll just go to the next code. So I create I, set it to 1 initially because in MATLAB, indexing starts at 1. In other languages, you don't have to worry about it since you're only using MATLAB, but in other languages, it's actually convention for indexing to start at 0. Arrays always start at index 0, but in MATLAB it starts at 1, which is fine. Just know that it always starts at 1. So or if you wanted to start at a later value, you could also do that. So you wanted to skip the first element, you could just start it at 2, and then it would start at 19.05 and then go all the way to the end. Or you could even stop early. Maybe you wanted to stop early, so you do the length of coin diameter is -1, it would skip the last element. So it would go to the second to last element, and then it would stop there. And this colon just creates a range. So it creates a range from 1 to the length. So that's defining the first like header of the for loop is what values of I are you going to use? And you don't even have to name it not I. You can name it, I think in MATLAB it's convention for you to name it IDX or something in your other assignments, I think. Normally you just name it I. And if you do a 2D or like if you want to traverse a matrix, or in other languages it's just a 2D array, then you would use a nested for loop, so a for loop inside of a for loop. So first you would go through each row, and then within each row you would go through each column. So you can do that, but in this case it's just an array is one dimension. So you just need to go from I equals 1, which is the first element, to I equals the length. And it doesn't even have to be called I, it could be called watermelon. And watermelon is just your indexing variable. Remember, it's called the indexing variable. Actually, I call it the indexing variable. I don't know if there's some other proper name for it, but I've always called it the indexing variable because it's the variable that you use to index the array. An index just means an index in an array is a particular location. So the first index is the first element. The third index is the third one. The 10th index is the 10th element. And indexing is this, what I'm highlighting right now. I'm indexing it, so I'm going in colon diameters, I'm indexing it at the ith element. So say the for loop's been running for a while and now I equals 10. It's going to go colon diameters 10. So it's going to access or index the 10th element. And it's going to say if that element equals the diameter of a quarter, then subtract 25 cents from the balance, okay, because the customer is going to use that quarter to pay. The quarter's 25 cents, so I'm going to subtract 25 cents from the balance, and then I'm going to increase the quart count, or the quarter count, by 1. So set the quarter count to what it is right now, plus 1. Else, if the diameter of the current element that we're checking is the same as the diameter of a dime, subtract 10 from the balance, 10 cents, and add 1 to the dime count, and do that for all of the rest of them. So 5, 1. If it doesn't match any of those, if it doesn't match the diameter of a quarter, a dime, a nickel, or a penny, notice how there's no if here, because there's nothing else to compare. If it doesn't match any of these, then we don't even need to check anything else. We already know that it's not compatible. It's got to be a foreign currency. So we add 1 to foreign count. And that's it. It just goes through every element in the list and does this for each element. So you can imagine a for loop as is kind of just, if you wanted to not use a for loop, you would have to write this code that I'm highlighting. And let's imagine still that the list or the array is 30 elements long. You'd have to copy and paste this code 30 times, and each time replace I with the index that you want to check. So you would do like 1 for all of these, and then for the next block, you would change it to 2 and 3. But with a for loop, you don't have to do that. You just write the code once, and then I is the thing that's changing, kind of like a function in math. X, or the domain, is your input, and then you get some output out of it. This is like a function. For every x in the function, for every x in f of x, do this. Is basically how you can think of it. Next, print all of that stuff out. I think you know how to do that. And then if the balance is 0, the customer has paid in full. because the customer doesn't owe anything else. If the balance is less than 0, so their balance is negative now, which means they overpaid. Then you can say that they overpaid by how much. That would be the balance. You could also do absolute, I don't know what the absolute value command is in MATLAB, so I just did times -1 to make it positive, and then divide by 100 to turn it into dollars, because right now balance is in cents. Otherwise, if it's not 0 and it's not negative, so if they didn't overpay and they also didn't pay the exact amount, then that means they underpaid. So you don't even need a conditional here. You just say else. And that's what this is called. This is called the conditional statements. So conditional statements have booleans like equals, the double equal bar, checks for equality. There's also a triple equal bar. I don't know if apparently MATLAB doesn't do that, but in other languages there's a triple equal bar, which basically is more strict on equality. So the triple equal bar will actually check if they're the same pointer, or if they have the same pointer. But that's a whole different story. What was I saying? Oh yeah, Boolean values. So you have equals, greater than or less than, not, which is the exclamation point, and, which is 2 ampersands, or, which is, in MATLAB it's 1 vertical bar, and like every other language it's 2. I guess MATLAB just wants to be different. MATLAB's not like the other girls. And all Boolean operators return either true or false. That's why they're called Boolean operators, because a Boolean is either true or false. It's not a numerical value. It's not a text value or like a string. It's just true or false, like on or off, 1 or 0, yes or no. It's just true or false. And so you could do if. This returns true or false. So behind the scenes, when the code's running, the interpreter, I'm pretty sure MATLAB's an interpreted language. Yeah, it's a script. So it's an interpreted language. There's no compiler. Well, kind of a compiler, but it probably just optimizes stuff. It doesn't really compile it to any kind of IR code. If this will be replaced, the interpreter will just see this as true or false. So let's say balance is equal to 0. Let's say balance is equal to 0. This is just going to replace with true. And it's going to say if true, then the customer has paid in full with no excess. And whatever's in there, if the thing inside of the parentheses is true, it's going to do it. If it's false, it's not going to do it. There's also a thing called a ternary operator. I don't know if MATLAB supports that, but let's say we want to check if 1 equals 3, which obviously isn't true. But here's the true condition. If it's true, then do this. So we'll do like display true. If it's false, display false. And this is just shorthand way of doing if statements, kind of. Yeah, MATLAB doesn't support it because MATLAB's dumb. You should be learning a real language like C or I don't really like any other languages other than C. Or like even JavaScript is okay to an extent. Here's question 3. So question 3, we'll go through, I forgot, what is this? Oh yeah, the jet. So actually I'll make a separate video on this. I'll end the recording here. I'll make a separate video on this so that this one isn't too long. How do I end this? up here.